guess it's my time. Yep. Well, hello, ladies and gentlemen. My name is Jusin Suh. I was a packaging intern working underneath Travis Wesley. He is sitting over there by the window. So for my agenda, for my presentation, I'll briefly talk about myself, and then give a little brief background about me, and then I'll walk through my projects, give the key takeaways, and just highlight some of the adventures that I've had throughout my time here, and give some shout-outs, and I'll open up for any questions. So, a little bit about myself. My hometown is Skokie, Illinois. That's a northern suburb of Chicago. I was born and raised from Chicago, and I also attend Michigan State University. I'm a senior. I study mechanical engineer, and I'm hoping to graduate in May 2018. I'm also a participant and a member of the men's club volleyball team at Michigan State, and I played as a libero, a setter, and also a defense specialist. I have a passion for the game, so I coach club, I coach college, and I also coach high school. I also was a member of the professional society called Society of Agent Scientists and Engineers, and so for the past year, I was the co-president for that organization. And then, welcome to the land of Clorox, ladies and gentlemen. And so these are some of the projects, some of the bigger projects where I felt like I made an impact to, that I worked on during my time here. And so as you can see, I really was fortunate. I really got to get involved in all these different businesses that we have within Clorox. So I was fortunate to be involved in the charcoal plant, the food plant, and also the Glad plant. But as you can see, I was really involved. Most of my time was really put into our food plant in Wheeling with our Hidden Valley product. And so that kind of leads me into my first project that I'll be talking about. It's a Line 4 Loss Street project at Wheeling. And so basically what this project was to really capture the losses of the production line based off 4 M's and the 1E. And so the 4 M's are the man, material, method, and machine. And the 1E is environment. And so I'll talk about more in depth that later on. The FAT Guideline and Tool project was something that was collaboratively worked on with my peers from the engineering group. And that kind of helped me with my FAT Amperage palletization project, and I'll talk about that later. So the Line 4 Loss Street project, the scope of the project was to create a manual that's data to clarify the understanding of downtimes and discover possible solutions. The purpose of this was to increase the efficiency of the production line and have data record of the production line's performance. This line in particular doesn't have any record of its performance, so it's key that I was out there spending time on the line and keeping record of all those downtimes that we have, and have some data that we can show to the plant. So this is a brief overview of the line. What I really want to stress out here is that this line is really driven by the temp workers. There's 3 line operators, 3 full-time line operators. There's 1 temp at the palletizing station, and then 6 temps at the packing station, 3 on both sides, 1 temp at the material station, going back and forth from the unscrambler and the capper, restocking bottles and caps. And so that gives a total of 11 workers. So there's a little bit of a difference of dynamic here in this production line compared to the other lines. Usually you have 4 staffs, operators, but this includes 11. And out of those 11, 8 of them are temp workers. So it's a huge impact to the line and to our efficiency when we don't have a temp worker. That would mean that an operator would have to cover up for a temp worker or something, you know? And so that's key, but that's kind of what I want you guys to keep in the back of your mind, because I'll bring that point out later. And so basically where my work came in was where I created the manual length data, capturing all those losses. And so to spend time at the production line just observing and making sure I know all those downtimes, that when they occurred, how long it happened, how many times it happened, and what they did to resolve that issue. And then I would give a data analysis and present it to the plant. But also during my other time, I would be really creating a bond with the operators, trying to get a perspective of what they think about the production line's performance is. And so one question that I came across was about line speed. I asked them what the line speed of the line was and where they usually got it. And the operator took me to the unscrambler, which is at the very beginning of the production line. And so I was a little skeptical. It raised a lot of questions to me. I was wondering, why are they getting the line speed at the beginning of the line? It's not as accurate as it's supposed to be, because with usual lines, the other lines, you usually get the line speed off the filler, and that tends to be in the middle of the packaging line. And so that raised a lot of questions. So what I did is I raised that point up. I raised that issue to the project engineer for this project, Jordan Leary, and I told her about it. And I was asking her all these questions. And we decided to verify the line speed. So what I've discovered here, there's a lot of numbers here, but there's only two numbers that really you need to know about. Is that number right there, 172. So what I've done is I went to the filler, I counted how many bottles it produces in a minute, and so in an average rate, a time span of a minute, they produce 172 bottles per minute. Our rate is set at 240. That's what our planning rate is. And so the discrepancy that we have between those two numbers is 29%. And that is huge. That's about a third of our production. That could be going into our efficiency, our overall equipment efficiency. So that's a huge loss. And so I kind of look deeper into that 29%. What does that 29% really entail? And so what I've discovered is that there's an 8% of that 29% coming from rate loss, which means the filler itself is not running fast enough to hit that 240 bottles per minute. And then there's that 21% of that 29%, which means that the unscrambler is not producing, it's not feeding enough bottles onto the line to hit 240 bottles per minute. And so what does that mean? And that means that, basically, it means that our production line is not even capable of running that 240 bottles per minute, that theoretical or that planning rate that we've had in plan. And so that's really crucial, and that's something that I identified. And then I've also spit out some recommended solutions for the plant. And so, for example, with line 1, the paste rep, contact the paste rep, and that was basically the vendor who installed that unscrambler at our production line. And so I stated it, and then I decided, I was wondering if it's feasible or not, and it would cost money, but it would be a responsibility of the engineer to take care of because it's the packaging equipment. And so that's just one example, but an example of an unfeasible recommended solution would be compensate by increasing the speed. We're already setting the machine at its max already. So if we go any higher, it can erupt a lot of other issues. And so that would not be feasible. And so the key takeaway of this project was to be curious, really. Ask questions. By asking questions, you're being more active rather than being more passive. And so it brought me where my intention was going into this project was to really just go out there and just collect some data and do some data analysis and present to the plant. By being curious, it really driven me to find something bigger, look at a bigger picture where we are so heavily focused on the temp workers, but that's not where we're getting that big loss from. We're getting the big loss from the machine's capability, right? And so that is crucial, and that's what led me by being curious. So the second project I talked about today is my FAT guideline and tool. The scope of the project was to create an FAT guideline and tool to help the advanced understanding of the FAT and of how to conduct an FAT in a concerted way. So for those who don't know what an FAT is, FAT stands for Factory Acceptance Test. And so it's a formalized process to determine whether or not a system, most likely an equipment, meets its specifications. So that could be their quality specifications, their performance, their design, really anything. And so with that being said, it kind of leads me into my purpose of the guideline and the tool. The purpose of the guideline was because to really capture all the ideas, all the components in an FAT in one document, and really not make it into a manual where it's like 20 pages, but really to make it brief and get straight to the point. And so it also entails the tips and things to consider. There are a lot of things that go into an FAT, and you can miss out on a lot of things. So with my experience and with the experience of my peers, they've included their tips and things to consider for the different components within the different components of the FAT. And it also identifies all the checklists, so that could be a safety check. There's a lot of documents that go into safety. So that's what it does, and the purpose of the FAT tool was to really consolidate all the documents and the needs that you need in one place. So when you conduct an FAT, it makes it a lot easier. All your documents are in one place, and it's it's created as a template format to really make so you can modify whatever based off your needs, whatever your project is. And then it also brings a lot of discussion points, especially with those record sheets that are in there for your tests and also your punch list items. But you can, I'll kind of briefly go over what is in the FAT guideline and the tool, but I'll kind of go more in depth. You'll kind of get to see more in depth with my FAT tool in my FAT Amherst palletization project. So right here with the FAT guideline, this is just an example of those tips and things to consider. You know, so especially for a test material, you got to know your input and output when you're testing your equipment. And so some things that you need to consider is when you're testing your equipment, you got to know how you're going to put those products onto that equipment. Are you going to hand stack it? Do you need an extra conveyor? And so those are things to consider. And the bottom here are this checklist that I mentioned. Here on the right is just to get that idea of the components within an FAT. It tells you all goes from what an FAT is, all the way to preparation, and then an inspection, and also even the pre-FAT. This is an example of the FAT tool. This is just a documentation checklist. What I really want you guys to get out of this one is that there are tons of documents, but it doesn't mean that it pertains to your specific project. And so I've identified some of the key documents that you most likely will need, and I've attached a Word document that's in a template form and has a lot of examples in, and so you can really change it based off your needs. This is just a record sheet for the steady state test. The two things that I want to get out from this is the acceptance criteria. So basically on the top, you're going to have the criteria of what needs to be successful for this test to be successful and the FAT to be successful. And so you would state that at the top, and then you would also I've also included a priority column where, so in an FAT, you're not going to be able to run all the products that you have in plan. And so you might want to prioritize them. And so, time could be a constraint, so you just prioritize them and say which ones you want to run with high priority at first. So with that work, it kind of leads me into my FAT Amherst palletization project. The scope of the project was to conduct an acceptance test on the new conveyor system. The purpose of it was to validate the equipment meets all specifications and functional requirements. And so as you can see, this is just a drawing, a CAD drawing of the equipment that we had at our Amherst that's our conveyor system. It has all these different components. So for instance, like the scan toner projector would scan all these different kinds of boxes or these cases that would go through and see if there's any defects, and if there are, they would just reject it. So that would be the functionality of the scan and the projector. This is the FAT punch list that I've created, and so this is kind of neat because it also has that priorities section, and then the date, and then it also tells you what equipment it is, what that punch list item is, and so really for this punch list, this comes really in handy when you're inspecting the machine or when you're doing the actual FAT, because you see any faults in the specifications or the equipment of this functionality, you gotta write it. And so I've also included a color indicator saying blue would be like it's resolved, gray would be something that has a finalized solution, yellow would be something that's critical that we need to get on to right away. And so this is another sheet that's in the FAT tool it's called the responsibility sheet that I've created. And so I've laid out a diagram of where all these different locations for the different components of the equipment. And so, when you're conducting an FAT, the last thing you want is someone to be just sucking on their thumb and just literally sitting there and talking and not doing work. You want to be as efficient as possible. So what I've done is I say to everyone who's a participant in this FAT and told them exactly what location they're going to be, what tool they are going to need, and their job description. So for example, for me, I was a data collector and I was at location 4 overseeing the whole entire equipment, and I had my laptop. My responsibility was to collect data for all the tests and also make sure that we were running the products that we had in plan. This is the record sheet that I've created for this FAT. Again, highlighting that acceptance criteria, we have the gapping requirement and also our changeover time. That is an acceptance criteria that we need in order for this test to pass. And so laying out all the products that we ran, the priorities and the criteria, and then determining whether it passed or failed. So that leads me into my takeaways for this project. I think being bold and communication goes hand in hand. What it means for me to be bold is taking initiative and taking risk. For me, jumping into this project halfway, this project has been going on for a long time, and for me to jump in and tell people what to do, that's where the bold comes in, and also communication, making sure you're delivering the right message. And when we have discussions during meetings with our vendors or with our project team, communication comes in hand right there. And so my adventure here, I had the opportunity to volunteer at the Mission Elementary School. I was also at the planter with my peers at the Atlantic West, or at the main Atlantic plant. And then I was also an operator at the wheeling plant for 2 hours, so that was pretty fun. And I also, this is just a fun event at an escape room with my engineering team. I got to zip line around the Smoky Mountains, so that was really cool. And this last picture really captures my heart because coming to somewhere, it's brand new, coming to Atlanta where I didn't know absolutely anyone, and really finding a community means a lot to me, and I got to find a community within a church. And so these are all people that are in my church who are in the same boat as I am. So coming somewhere that's brand new, just looking for a community, people to hang out with on the weekends. And so that was really nice. And I just want to give special thanks to the packaging department, wheeling plant, Larissa, Gabby, Deanne, interns, and the SCLDP mentors. And then I'll open it up for questions. No questions?
You told us everything. Awesome. Awesome. Thank you.
Yep.
Thank you.